Okay, welcome everybody. Uh, Welcome to our Cloud Native Qumulo exclusive. I'm super excited to go through and show everyone what has been brewing and being built for years in the making. A lot of hard engineering work, and I'll turn it to my colleagues to go through the details. But first, quick introductions of who we have on the call. So, for those that have been to really any Qumulo event for the past, we have some familiar faces, some new ones. Crown Bregetsport, our CTO and head of all things product and engineering. To up the IQ average on the room, we also have Mike Schmiel, our principal SD and Qumulo engineer, who's going to go through the live demo of everything Cloud Native Qumulo. To make a bit of a balance more back to my level and talkability, I have invited Paul Gallo over from a former past colleague of mine there at AWS as the storage go-to-market and sales leader to give some perspective on what customers are seeing on the market, what problems they're facing, and how ultimately together we can collaborate to help customers realize the true full vision of a cloud native file system on AWS and ultimately advance their ambitions. So with that, today what we're going to do is go through a couple quick things. One, let me just quickly pause for a moment and talk about what we mean by Qumulo Cloud Data Platform. So this is really our vision to help customers connect seamlessly from edge to core to cloud and be able to do it in a way that is the same uncompromising experience, if not better, in all places, and seamlessly connect data to users and applications and compute, no matter where they are, between regions, between clouds, between hybrid on-prem and cloud as well. Today, we'll be talking through kind of an intro of what Cloud Native Qumulo is. Most importantly, I'll do fairly quick on that, then we'll move into live demos with Mike leading, and we'll add some color commentary as the plays go through. And then open it up to participant Q&A, and hopefully get some great questions to further discuss what we have going on here. So first, a quick intro on Cloud Native Qumulo. First, it's a full-featured file system, decade plus in pedigree, very mature, fully customizable, elastic, a very new way related to a non-provision capacity or performance capability deployable in your tenant with your control and very disruptive economics. Let's break those down real quick. First, from a full-featured file system perspective, all the enterprise class feature functionality you'd expect from a protocol layer, a true multi-protocol protocol layer, all data through all protocols at the same time with full permission enforcement, a truly independently and scalable performance and capacity architecture, single global namespace, single volume, no matter how big you want, unlimited file size, file count, file system size, and all the expected security and access capabilities for even the most robust environments to take care of. 6-time Gartner Magic Leading Quadrant leader for Qumulo and moving even further in the future. And from an underlying architectural perspective, what's really unique about Cloud Native Qumulo is, in my opinion, it really fulfills the core tendencies of being cloud native. That is true elasticity, true massive scale, and most importantly, while doing it, paying for only what you use when you use it. So you can be extremely cost effective along the way as well. What that starts with, it's a full disaggregated architecture from storage to compute. So there is no bounding together. There's no lift and shift of kind of replicating an on-prem node architecture. This is really one of the first ever in the world truly disaggregated in cloud architectures that allow you to have the scale, durability, and economics of S3 while having the performance, rich data services, and protocol application compatibility of a file system. And we support all the underlying S3 object tiers, even S3 intelligent tiering or Glacier instant retrieval, and the ability to configure both the number and size of instances based on the performance needs of a customer on the fly. In fact, you can scale the system from as little as 1 gigabyte a second of throughput, kind of idling at our minimum configuration, up to hundreds of gigabytes a second of throughput within minutes. We'll see some of that today, and then shrink it back down as well. Very important. That true elasticity where your performance on the file system matches the performance on the compute layer to really be truly elastic. There's no need to provision capacity, just like S3. You pay for only what you use when you use it. The moment you clean up a project, you stop paying for it. And that way, you're not having to preemptively kind of provision capacity, pay for what's provisioned versus what's used, and you get tremendous economics because of it as well. Fully deployable in your tenants through very simple CloudFormation and Terraform. You'll see some of that today, and makes it very easy to scale it very quickly. And lastly, but for a lot of customers, very just important, disruptive economics. So pricing for our software owned licensing starts at $24 per terabyte per month for our hot high performance system, and only $8 per terabyte per month for cold. All in, depending on customer discounts, depending on what tiers, what performance, we generally see customers in between about $25 to $50 per terabyte, all in for CNQ hot, and about 10 to 15 for cold. This is fractions of what alternatives offer, and really does break down the traditional barriers, where now it is disruptively equal to, if not sometimes better than, on-premises alternatives, especially when considering that this is multi-AZ durability and availability, and allows customers to get a lot more out of a single instance than what normally you'd see from even a primary and DR replication on premises. So with that, that's the quick intro. I wanted to go through that fairly quick, because you can find a lot more information on our webpage and go through and play around with even a total cost of ownership modeling and everything from that. And really turn over to the main reason for this today, which is to go and see it in action. So with that, Mike, I'm going to stop sharing and hand it over to you.
Sounds good. Thanks, Brandon. Okay, let's get started. So what I'm going to start out with here is deploying an actual CNQ on AWS. So I'm starting out here on the command line here. I'm going to be using Terraform in this case to actually do the deployment. And then on the right in this big window here, I've got my AWS console, which is going to kind of mirror what I'm doing on the command line there. So I'm going to start off with creating some S3 storage, and then creating some VMs to be our compute layer. And so I think that those VMs should be already started. Here we go. So we're going to have 4 VMs to start with in this case. And then those are going to be initially pending right now. And then they are, in this case, the i4i 8x large instance type. So this is going to take a few minutes here, not too long. And I think I'm going to pass it back while this is going, but I'll let you know when it's ready to go.
Yeah, so really kind of talking through that. So, we have a 4-node minimum, or 4-instance minimum with EC2. So that provides high availability, multiple parallel paths for clients to connect. Is there certain type of EC2 instance types or otherwise that customers need to be considering when deploying this?
Yeah, we're generally using I think it's called the storage optimized instance types to begin with, because they come with the ephemeral or local NVMe disks, which we can leverage as a read caching layer in front of the S3 storage to optimize for both cost of access to S3 for repeatably read data, because S3 does have those transaction costs, and then also for latency, because those NVMe disks are much lower latency than S3 would be.
Got it. And I think from a family perspective, that's like the i4Is, the M6 IDNs, even if people still have i3 ENs or something, they could probably run on that as well. As long as there's a little bit of NVMe, some compute memory, then we're good there, right? So lots of flexibility.
Yep.
Fantastic.
Absolutely.
Just curious, like, could you, if you started with like i4Is, could you switch to M6 IDNs if you wanted to?
Absolutely. I think later in this demo, I might give you a little preview of some of that switching around.
Fantastic. Now, time to value is really important. Paul, maybe you can chime in here. Like, being able to spin up a system really quickly. We're going to see in just a moment live how fast it is. Normally would not be done live because we'd be sitting here for maybe 30 or 40 minutes. But maybe, is there any experience you have with customers related to that type of agility and speed that really makes a difference?
Yeah, definitely. You can hear me okay, right?
Yeah.
Uh, yeah, I think like when you talk about the speed to productivity or time to innovate, right? It just I think like a good relation is just like think back to what you would have to do if you wanted to try to spin something like this up on prem if you had an idea. In the case of like generative AI today and artificial intelligence, a lot of ideas get spun up. But like if I wanted to go like execute on an idea, I'd be thinking I'd have to design it, I'd have to negotiate through it, I'd have to go through procuring, I'd have to ship it, install it, implement the software on top of it, the networking, the compute on top of that, and then I can actually go deploy what my idea is. So, and I think what this allows you to do is not only deploy fast and get your idea out there faster, but also fail faster. I think that there's many cases where we'd have to go in internally to go ask for tens or hundreds of thousands of dollars and go ship all this equipment out for an idea, and the idea might not pan out as much as you'd like. And in AWS or the cloud for that matter, you can spin things up and spin things down. You can fail fast. You can turn it off if you'd like to. I like to coach our people here at AWS that there's really three sales to a customer. It's not a sale to get to the purchase order. In the case of like a normal on-premises business, there's a customer has to say they're going to do something. They have to like it and agree and say yes. They actually have to go do it and migrate it here and spin it up and deploy it. And the third one, which is the most critical, which is the customer happy? Are you happy with your result that you've gotten out of this? Because if not, you can delete it and go away, and that you have that ability to kind of shift the risk to AWS and take the risk off yourself in that case.
Oh, that's an interesting concept of shifting the risk. I hadn't thought about that. Okay. Yeah, I mean, so I mean, from a customer perspective, especially with some of the new use cases on the AI space, the Gen AI space, like being able to quickly spin up an instance to accelerate data off of S3 at the end of the day, under the covers, that's kind of basically what it's doing as an S3 accelerator. Really intelligent preemptive caching, 95 plus percent of all the IO coming out of NVMe, kind of ridiculous stats there. And also, that reduces the cost back on the API side. Let me ask, I remember from my time there as well, but maybe you can expand on it. Customers are today, when thinking about moving workloads into the cloud, right, have really two paths. One, a kind of lift and shift, or two, re-platform and try to make it, like S3 native. Being that this really approaches the cost of S3 on its own and yet still has all the protocol stack, do you see that as a new option maybe where they don't have to pick between those two? They can kind of keep the original application but get all the benefits of S3?
I do, yeah. I think it's really interesting what you guys are doing. First, I'll say like, look, we have many different storage services. Overlap is good. It lessens the amount of gaps that we have in our portfolio to kind of help our customers. But I think you're solving some challenges that our customers have, right? It's like a multi-petabyte, multi-protocol, scale out high performance file system, yet solving that kind of like total cost ownership challenge with a exciting new design that you guys have in the cloud, leveraging S3 and all S3 and the Glacier instances. I think that that does kind of help a customer kind of make those determinations of like, do I have to go through an 18-month process of refactoring my application to get to the price point that I'm really looking for out of it?
Yeah, perfect. Hey, Mike, I know it's only been a couple minutes. How's it going?
Yeah, we are set to go. So let me bring the
Oh,
screen share back up here. So that deployment finished here. I did run it with the time command to keep me honest. So it looks like in this case took about 5 minutes, 36 seconds. And we've got an IP address here spit out for one of those VMs. So I popped that open up here. And we've got our Qumulo cluster UI here for the file system. So
yeah.
if you, yeah, go ahead.
I was gonna say now, Mike, I assume now we have to, I don't know, do hours and hours of CLI configuration and like tuning to get this ready, right?
Oh yeah, of course not. This is ready to go, ready to go. And as part of ready to go, why don't I actually start a workload here? I have some client VMs running in AWS already, and so I'm going to kick off a workload against this system, and show it running.
Okay, we'll see some load come up. Well,
Yeah.
while that's starting to load in, Karan, maybe I could ask you a quick question, which is, from a original design principle back when, C&Q was just a twinkle in the eyes of some brilliant engineers and yourself, for example. What what were some of the core tenets that we really wanted to solve to be disruptive in this space and really make customers have a new experience here?
Yeah, thank you, Brandon. Look, the name says it all, cloud native, right? I had seen outside in before I came about a lot of attempts at essentially doing a lift and shift. And to be fair, our first instantiation was also a lift and shift, which is okay. It's not bad. In other words, you're taking your software from on premises, you're using EBS volumes instead of drives, you're erasure encoding on top of that. That seemed to be about the state of the art of the possible. And we certainly felt that, especially in the cloud and in AWS, S3 is a thing of beauty. I mean, it is amazing. It's got unbelievable resiliency. It has got fantastic performance. I compare it to a 1,000-lane freeway. You can go move across this in incredibly wide amounts of data. The consequence of that is actually the latency of each operation is not what file systems want you to have. And that's kind of the challenge. And what the team came up with is really complete disaggregation of data from capacity, from performance. And that was a core principle. The core principle for us was be truly cloud native. And what is cloud native? Use the primitives in the cloud, which is EC2 instances, instance attached NVMe, it is EBS volumes when appropriate, it is S3, the various layers of that, it is native networking, nothing funky. Those are cloud native primitives, and then build something which has got the characteristics that people love in the cloud, which is elasticity and agility, really, which means spin it up fast, start using it very effectively, spin it down fast, change quickly. And that's powerful for user agility and economic agility, right? Paul talked about it. When you're done with something, you want to be able to spin down. And that's a big transformation in the way you think about it from on premises, where you're absolutely building something to close to peak utilization because you don't want to run out of capacity. With that, I'm going to turn it back to Mike because he's got load running. Walk us through what we are seeing here,
Yeah.
Mike.
Yeah, so exactly what you're saying about the disaggregation there. This is what I'm going to be showing us next, which is I've got this workload running here. In this case, it's maxing out the network bandwidth of the 4 instances that I had deployed. But I know that my workload can go faster. I'd like to burst that performance up higher. And so in that case, what I've kicked off now in this top left window here is a script to manage some scaling. And so what I'm going to do here is I'm going to go from just those 4 VM instances that I had that is kind of limiting my performance right now. And I'm going to scale that out to be 12 of those instances instead. And so what I should expect is that my workload can then ramp up and be from 4 to 12 nodes. I'm expecting my workload to go from say 1x to about 3x of where it's at. So in this case, we've got running at about 9.3 gigabytes per second. So I'd expect 27 or more gigabytes per second when this is complete. So I kick that off and should expect that to complete in the next just couple minutes or so.
Yeah, now the 9.3, so if I'm not mistaken, when looking up the iFries, like that's pretty near theoretical for that performance.
Yeah, that's right. That's right.
Yeah, and that's one thing that's also an important factor when considering performance is like, look, you're paying for those instances regardless if you get it all or not. So getting, 95, 96, 98% of theoretical out of the software is really important to obviously still get your full, dollars worth, so to speak, related to it. Not always the case. In fact, pretty atypical comparatively to most every other file system out there. Paul, it reminds me kind of thinking about from a use case perspective. Are you seeing any interesting use cases where this kind of on-demand within minute scaling would be effective to be able to, respond quickly to a business shift or a I don't know, different thing coming in and being able to scale out as fast as possible? Are you seeing use cases like that? Maybe describe a couple of those.
Yeah. First of all, I haven't seen I haven't talked gigabytes per second in throughput in a long time, but getting 9.3 gigabytes per second out of a 4-node cluster is pretty impressive. Relating that back to my old days of scale out NAS and what our previous systems used to do. It's
Yeah.
pretty interesting. But to answer your question, yeah, I mean, we talked about like Gen AI tests and POCs and that kind of stuff. I think that is one like today where that really resonates with customers because everyone seems to have an idea to go spin something up, or even like a top-down initiative from an executive that's saying like, what are we doing with Gen AI? And a lot of people are kind of testing internally to try to come up with something that's of value, not just a chatbot, by the way, like actually building Gen AI into applications and creating new ideas to create new revenue streams or better an internal process or create a better customer experience for that matter. So I think like the testing POC stuff, yes, absolutely. But I think like one of the things that where this specifically hit us really hard was during COVID. Like customers that like ISVs, independent software vendors, that their business scales up and scales down. Digitally native cloud, born in the cloud customers that build their entire business on the cloud, and during something like COVID comes along and completely starts wiping out some revenue streams for them. Well, you're already invested in all of this on-premises hardware technology, and that's really it's a hard pill to swallow when your business might take a downturn for a specific reason that's outside of your control. So like I do see that risk shifting that I talked about earlier being like super critical for customers, and just in the unknown phases of like whether that's testing and building something new, or whether that's looking down the line of like something that could happen in the future that could impact our business that's outside of my control, and I have the ability to scale up, scale down. I think that's why customers are choosing the agility of the cloud, is for those unknowns. Whereas, I mean, look, we all know if you're on this call, like you've either sold storage or purchased storage, and I think everyone would resonate with the idea of you go buy a petabyte, or it could be 10, or it could be 100 petabytes. And you're taking on a risk of buying all of that storage, and you're only using maybe 50 to 60% during that lifespan. So you're over committing yourself and making a massive investment and taking a big risk in that sense, hoping that you're going to use all of it, where in doing that in the cloud, that's never the case.
Yeah, I mean, I think it was a big shock to the system. I remember, once COVID hit, and then post that, where 12-year bull market growth, everything's great, just no penalty for doing what you've always done and refreshing those systems. And all of a sudden, agility and flexibility become the most important thing in the world. And
I think of other things too. Like you asked for specific examples. Like just like off the top of my head, where I think like this really fits. Like first of all, going back to like the scale out file system, multi-petabyte, multi-protocol, like what industries do they fit the most in? You see a lot in like life sciences, genomic workflows. There's customers that are outsourced genomic houses, where like customers come to them to outsource their genomic studies. In that case, like, wouldn't it be nice to spin things up and spin things down when you have a customer that hires you to go do it, versus going and having to size for the largest ahead of time? A post-production shop in media and entertainment, like if people are doing jobs for customers of theirs and they're being hired, and you're going to spin up a ton of compute and a ton of capacity, and you need the performance on both ends. But if you had to go build that out on premises, what would you have to go build? You'd have to build for that high end, right? So that's scary for customers, and it requires a large investment up front to go do that, and a lot of planning, deployment, operational management on top of it, of the data center. So I think like things like that, where businesses can go up and down, it really helps customers kind of with the idea of risk shifting.
Hey,
Yeah.
while we wait, let me just jump in and ask a couple of questions that I'm seeing coming in from audiences already, which would be, I think, relevant to everyone. One question for you was, how are upgrades handled in AWS cloud instances? I guess it'd be the same as on premises. The answer to that is yes, you are right. It's very similar to that. It's software being upgraded and you're managing it yourself. There's a couple more that I'm going to get to, but you want to go? Are you ready to go? Show us the power of the scaled out C&Q, Mike?
Yeah. So I'm still running that same workload here, and so while that was running at that 9.3 gigabytes per second, if we remember, I was doing that scaling out to 12 nodes here. So in this case, took around just shy of 6 minutes, and most of that time is really spent in not in any kind of downtime or anything like that. It's spinning up the new resources, getting them prepped, ready to go. And then there's just a really short period where it's like, okay, now we're going to add those new resources into the system, and just a little tiny blip to the workload. And then we can see the workload was able to then scale up itself all the way up to nearly 28 gigabytes per second is where we're at now, which I think if I do some quick math here, 9.3 times 4 or times 3 would be 27.9 if I did that mental math right. So yeah, we're seeing the gains of having those extra resources there for us. And
So
then I believe
that's,
the workload is finishing out just now. Yeah.
yeah, so true linear scalability there on that performance. It sounds like it continues to be the case that the bottleneck is almost always just maxing out the network bandwidth of the EC2 instances there. Is that an accurate statement, Mike?
That's generally speaking, yeah, where we're gonna come down to.
Yeah. So super efficient use of the hardware, true linear scalability. So now, real quick thoughts. That was going from, I don't know, relatively small i4 i4 XLs, just going from 4 to 12. Um, could you also go from 4 XLs up to like the 32s if you wanted to max out?
Absolutely, yeah. The kind of the range of possibilities in terms of instance configuration is available. So if you wanted to run, in this case, I was on the 8x larges, but if you wanted to run
Okay.
instead of 4 of them, you want to run 8 of them, that's fine. If you want to run 6 of those with the next SKU up, I think it's the 16x large, that would be totally fine too. If you want to run 40 of the 2x larges, go for it. The options there are all on the table really for the
So
right way to configure kind of both the SKU or the instance type being used as well as the number of them.
yeah, and so kind of more concurrency, maybe more nodes, but more bandwidth, single stream bandwidth, maybe larger instance types or
Right.
something. And the nice thing is
Absolutely.
really flexible. So if situations change, you change them on the fly. No need to, redeploy, destroy, completely reconfigure it, as we saw on the fly with client load hitting the system.
Yeah. So like to take advantage of some of that, what I'm going to do next here is kick off this next piece, which is going to then take this cluster that I have and scale it back down. But I'm not going to just scale it down to where we started, where we went from 4 of these 8x larges up to 12. I'm going to take it back down to 4 nodes, but in the process, I'm also going to replace those 4 nodes with 2x larges instead of 8x larges. So that's a fourth of the compute power that from where we started. And so I'm going to do it. It's basically an entire cluster reconfiguration here, where I'm going to introduce 4 new VMs, which are the future compute that this is going to run on. That's going to still be backed by the same S3 layer, of course, and that's why we're able to entirely swap out the compute resources that are running, and take this down to more of, imagine like maybe we want to run in a little bit more of a maintenance mode. Our kind of peak activity has finished. We want to scale it all the way as low as we might want to go to be able to have still a running system, but maybe not pushing it with the same level of load. So I'm going to I kicked that off, and we're going to wait probably another 5-6 minutes till
Hey,
that's.
while we are waiting there, a couple of things that I want to just point out, if I may, Brandon. Number one, all of this is happening live. It's happening while load is going on. So you're not taking a downtime from a customer point of view. So that's a pretty big deal. And there are a few more questions, but we can get to them one after the other. But I'll hand it off back to you after having sort of emphasized that again.
Yeah, I mean, just floating the IPs, the client are still connecting, everything's going on while it's adapting. And by the way, for the scaling down thing, I think the first thing that came to mind is, especially just coming back from IBC in Europe, a big media show and a big user group in Vancouver, a bunch of media customers as well. Like they love the idea of when artists aren't working, stop paying for things, right? Like spin it down, go to idle. And then, the next morning when they come in, bring that back up. And then, at a moment's notice, okay, now the production cycles hit a certain point. Great, I'm going to go spin up to, 50 gigabytes a second, 100 gigabytes a second, and crank out a big render job without moving the data, without using multiple systems, all in the same place. Kind of the golden rule of cloud, right? Which is to never move data if you can avoid it. Land it once, keep it in one place, so you don't have to pay for moving it back and forth. Paul, it kind of brings up another interesting question. One of the things that we've seen as well is customers wanting, always trying to cost optimize. And, in in AWS, one thing that I was always surprised by is the top, just the cultural principle around frugility around helping customers reduce expense as much as possible. Like instead of, I remember a customer once telling me like, hey, every single time my on-prem vendor comes, they talk about how they can sell me more. But most of the time when AWS comes in, they do an assessment and help me figure out how I can save more, right? And disruptively helping reduce price to keep it as competitive as possible. How big of a deal do you see, especially considering kind of the typical workloads we dealt with previous to AWS, being able to take advantage of something like S3 intelligent tiering, and really optimizing the file system to work well? In fact, it's kind of our default config for this for the hot systems. How are customers taking advantage of S3 intelligent tiering, and will this be a benefit to a typical file-based workload?
Yeah, I mean, first, I'll say like we absolutely do lean into cost optimization for our customers. I think we've dropped our prices somewhere around like 22 different times over the course of however many years. There's a stat out there that shows that. And it's no surprise. I mean, I think everyone's kind of read at some point about Amazon's leadership principles, and that aligns really well with our customer obsession approach and just working backwards from our customers. In a case of what you're doing, yeah, I think it's a really big deal. When customers look to tier just from a hot tier to a cold tier, we talk a lot about just like tiering from hot to cold tiers, but there's like multiple levels of cold tiers within S3 that you're talking about, and there's easy ways for you to manage that yourself and really control like at the app level or at the admin level of where you want to put data and when you want to put data based on different metrics of usage and those types of things. But there's also just leveraging something like intelligent tiering that will do it for you, and you can kind of just like set the amount of days. So I definitely think it's absolutely critical. I think we used to use what the 80-20 rule and just say 20% is being used and 80% is not. That doesn't hold true for every organization. I think it would look different in different types of workloads in different industries. But yeah, absolutely, having that ability is better than not having the ability. And I think we actually win a lot of opportunities with customers at AWS against our competitors because of our abilities and like tiering data down to different levels and dropping our prices and being customer obsessed. So yeah, I think it's a really big deal.
Yeah. Also, by the way, one of the demos we showed off at IBC in front of media customers was being able to, our integration with Amazon Q Business and Bedrock. And, I was surprised, with a lot of this stuff related to Gen AI, it's kind of I guess a quick, I'm skeptical, right, of the gimmicky versus like practical application circumstance. But there was a line of customers afterwards asking about how to go demo and try this in specific, because you could just simply ask the system as if you're talking to the cloud native Qumulo directly, what's going on, like what's my biggest project, how has it grown over the last 3 months, how much is this costing me considering I paid this and this, who's my largest user, and who hasn't cleaned up data, what user has the most data that hasn't been touched in 90 days, this type of stuff. I don't want to get artists in trouble, but at least from a top level perspective, this was really valuable. um, Considering that use case for media, are you seeing other use cases emerge in some of the other industries that would be interesting in a connection with a platform like this?
You know, I think there's a broad range of them, and I think a lot of them are ideas at this point in terms of like artificial intelligence and stuff. So I won't go into any like specific example of a particular opportunity or a use case, but what I will say is like everything that you just said about Amazon Q. By the way, I didn't know that, so it's good to know. But I think what that kind of comes back to for me is like the interoperability of the services when you move to the cloud, and everything you just said. Imagine having to do that if you were on prem, right? Like, what would you just had an idea of something to go do? Like, how would you go deploy that idea of like deploying an application on top of your storage system to go ask that questions to go come up with those things? Or you'd go buy an ISV that's going to cost you a lot of money to go do those things because they've been doing it for a really long time. But one of the reasons I joined AWS a little over 3 years ago was like watching reInvent videos of Andy Jassy saying things like, we work backwards from our customer. Customer asked for this, we gave them that. Customer asked for this, we gave them that. There's also a sense of like, when we release services, it's not necessarily like that service can do absolutely everything for a customer. It's iteration on those services over a long period of time. And I think interoperability is one of those things. Like when you bring your data to the cloud, you're saying that today Qumulo supports Amazon Q. Like, what will it support in the future? Like it's in AWS, and there's all of these things in AWS that you can do on top of your data. And I think that's a really important aspect of why customers are bringing data to the cloud, or in this case, would look to even come to Qumulo because of the future of what we have together.
Yeah.
Hey, can I just jump in here? I got a couple of interesting questions which are technical that I figured we would want to answer along the way while we are waiting for the scale down piece. One of the things that I want to go emphasize is, look, we are leveraging S3 in the backend for durable storage, and S3 is already 11.9s, highly durable, and we do some other clever things along the way to go make certain we've got belts and suspenders on top of that. But there's no reason to go erasure encode data in that. So that's one of the big savings from a customer point of view. You're not double paying for sort of a data durability, because S3 already gives you that in a fantastic way. The other thing which usually people are concerned about is, hey, how reliable is my solution? Because if you have all of your EC2 instances in a given zone, what happens if that zone has a outage or the zone has a event? That happens every once in a while. And in many ways, that is similar to what happens when your infrastructure in your given data center goes down. And typically, you're one of many ways of solving that. Hey, I have a DR copy. You could absolutely do that with Qumulo. But the cool thing is, and this is coming out very, very shortly, if we have not already announced it, and I'm myself lost in the details of what's there in what release, Mike. But we do support multi-AZ. In other words, you could take your EC2 instances that Mike Schmiel showed and spread them across your three AZs. So service availability is now also as durable as the storage, which is multi-AZ by definition with S3. So at this point in time, it's really hard to look anyone straight in the face and say you could do better cost effectively by building this stuff on your own in your infrastructure. It may be possible in certain cases, but that is for your base use case where you have 85-90% utilization 24/7. And in that case, it's absolutely worth it. You buy the base and then you rent the peak in the cloud. And the agility it gives you to go burst up, burst down in this incredibly resilient manner is absolutely nuts. I can't be more excited about this. So with that, Mike, go ahead, Brandon.
No, go ahead, Mike. Yep.
Sure thing. Yeah. So I've completed that process now here. We've got, something around 8 minutes in this case. And then we've got this new node or new system. Let me move my Zoom thing out of the way. And then let's pop back over to the instances here and see what we've got running here. Now we've got running these 4 new I4I 2x larges. And then all of the I4I 8x larges have been ejected from the Qumulo system and are ready to be torn down. They're no longer in use. And so what I can do too is I can go over to our nodes page here, and you can see we've got these 4 new nodes. So the first 4 were 1, 2, 3, 4. The next 8 were 5 through 12. And then now we've got this 13, 14, 15, 16 that are those smaller 4 instance types here, these I4I 2x larges. So we've completed our scale down, spending a lot less money than we would be with those 12 nodes, and even still probably something like a fourth of the cost of where we even started with the 4 nodes of the 8x large.
Yeah, now one of the things I brought up previously, but it'd be great if we could potentially show that, which is around being, truly multi-protocol. So, there's a lot of use cases where customers are editing via S3 multi-channel, and they're rendering via NFS, and maybe they have a media asset manager wanting to touch that data via S3. Instead of moving that around to different systems, how would we address that here instead?
Totally. Well, luckily enough, I've got a little bit of a demo prepped on this other desktop here to show you just that. So what I've got set up here is I've got 3 different users that I'm going to be using, and I'm going to mount them to the same Qumulo file system. So in the top left here, I've got a terminal window. I've got my user Mozart, and Mozart is going to be using NFS over Linux here. And then on the bottom left here, I've got a remote desktop session to a Windows machine. In this case, I've got Verdi running. and he is going to also mount the Qumulo file system, but over SMB instead. And then the third on the right here is going to be running under user Beethoven, and that's actually hosted on my Mac as a third platform. So let's get that started maybe. So I'm going to first mount the, let me grab this IP here from the system. I'm going to mount this to a directory, and I'm going to go into that. And so now I'm in the Qumulo file system here, and I'm going to create a file called Mozart on Linux and say hi from Linux. I'm going to save that file. I wrote that here. We should be able to see that I've got, this data is all that test data that I was doing before, but most recently I've got here this Mozart Linux file. It's owned by the Mozart user as expected. And then I'm going to go over to my SMB user here, Giuseppe Verdi, and he is going to go to this same IP address. That was 10.81.10.77, and go to the SMB root here. We're seeing all the same data, and we even see our Mozart Linux. Let's take a look. Oh, yep, that's hi from Linux, from Mozart. And we can take a look here too. Let's look at who our owner is there. Yep, that's Wolfgang Mozart right there. And what we can do too is we can add our own file here. And so this is going to be Verdi Windows. We're going to say hi from Windows. Save that. And we can see, as expected, this is going to be, yeah, Giuseppe's file. And then we can see back here, if I were to check my files again, oh, yep, there we go. That showed up. Let's take a look at that. Hi from Windows, as expected. And lastly, third protocol I'm going to go through here is S3. And so this one, first thing I'm going to do here is set up an S3, configure an S3 user. And so I am going to then use my CyberDuck window here. And we actually have a Qumulo entity built right in here. And so what I can do is I can put in my server address, and I've got my access key that I created, and I've got my secret that I've created, and I'm going to hit connect. Great. And let's take a look at what we've got here. Great. All my data. And what I'm going to do here is I'm going to write a file as Beethoven. So I'm going to drag in my Beethoven file here. Upload complete over S3. Awesome. And then what I can do is I can also pop back over to Windows here. Oh, it's already actually showed up. There's Beethoven there. Let's take a peek. There is my picture. Amazing. And let's look at who actually created this file. My properties is right under the Zoom window. Great. Okay. Security group here. We're looking, we see, yep, it's got Beethoven right there. And then we should be able to go back to Linux here and do the same thing and take a look at what I've got in here. Yep, I've got Beethoven, users Beethoven, and it's all just kind of seamless, all between all of the protocols there.
So this, you didn't have to like pre-script or command this out. This was out of the box multi-protocol.
Yes, absolutely, absolutely. All I've got is I've just got a mount point. The system even comes configured by default with an SMB and an NFS mount point to the root of the file system. And then this script here is really just one API that I'm using to configure an S3 principal for my Beethoven user.
Got it. So again, this is multi-access from NFS to SMB, then to S3, write and read, full permission mapping and enforcement across all the protocols. Therefore, true kind of single namespace collaboration across all those different use cases and users without having to move or copy the data. Does that sound right?
Yeah, absolutely.
Okay. Maybe now I could again turn it over to Paul real quick. Seeing what you just saw there, what are your thoughts? How would that impact customers and how they design solutions in AWS with something like that?
I mean, it seems super simple to me. And coming from a background of like 15 years of selling unstructured data, it's pretty amazing that you guys have built that out. So we're excited to be partnered with you guys.
Yeah, and another thing also to tie back to a previous thing I just wanted to point out. So the some unique attributes why I love the agility again that AWS provides and the flexibility here is, let's imagine there was an environment, a situation where one AZ did, or a service at a particular AZ went down, still having full availability for clients to seamlessly transition to the remaining two, but then also be able to spin up more compute on demand to be able to get right back to full performance, even in an outage situation. You can't do that on premises, for example. And you have 3 points of resiliency, not two. So you actually even have higher durability from a single CNQ instance than a primary to DR sync, snap and replicate on-prem. And that can really change a lot of the economics related to it as well. And then secondarily, imagine a backup or archive situation, right? Or a disaster recovery to cloud, where all of a sudden now you could have that sitting on a cold system on Glacier Instant Retrieval on the lowest compute possible, opening up for the backup windows and accelerating the compute just for backup when you have that backup window. But then in an environment of a situation of failover, you could make that instantly hot, right? You could scale the compute on that cold cluster up to tens of gigabytes a second to either rapidly restore or to failover applications into AWS. And so traditionally, right, there's the either cheapest Bitbucket possible backup, or there's the full business continuity at full price DR situation. This is really the best of both worlds. It's the lowest cost with the instant ability to go hot. And that's really hard to beat. I mean, being able to have that instant hot DR target is a pretty game changer for business continuity. So anyways, with that, let's see. I think that's it for the live demo. We showed everything, right? Perfect. Mike, I super appreciate it. I would say you made it look simple, but I would say it is actually just really, really simple. So I appreciate more that you engineered it to be that simple for all of our end users, so they don't have to, learn a bunch of crazy stuff to be able to operate the system so effectively. Karan, maybe we could turn it back and see what other now into our open Q&A with the audience section and see
Yeah,
what's brewing out
it
there.
is. There's a bunch of things which have come in board. I'll go try to answer some of the more technical ones, and I've got a couple of questions to tee up for you, Brandon. The first thing is from an architectural point of view, I want to go sort of flex in a little bit on some of these things, right? Number one is, how does this work? The data itself lives on S3. I already indicated that the data itself is in S3. It's highly durable. It's already multi-AZ durability. We ensure that service availability for your file system protocol and data services are also be multi-AZ available through the multi-AZ offering. And that is all running in the compute layer. So you had that slide up there for a second in the beginning, but I want to talk to that slide again, which is, how do we use the rest of the AWS primitives? We've talked about S3 and the variants of S3 all day long now, but let's talk about a couple of other things. What is running on the EC2 instances, which goes from 4 nodes to 12 or 20 or 200 and back down to thing? That's where all of the magic is. That is where you have the file system layer, which deals with storing files as opposed to objects. That is where you have the data services layer, snapshots, quota, replications, Active Directory integration, all of that. That's where you have the protocol. You've got S3 and NFS and SMB, all the variants. All of that is running on that EC2 layer, right? So what about other storage? You've hinted about NVMe, and you've talked about EBS. What's living there? What lives on the NVMe layer, which is really affordable, is essentially a highly scalable, globally shared across the cluster read cache. So once you read data from the object layer, it's invariably cached in the NVMe layer, such that the second reads and the third reads and the fourth reads don't go back to object. And it does do things for customers. Number one, reduces the sort of latency to that second read of that data, and more importantly, also reduces the cost because you're not going back to the S3 layer to go fetch that data again. Okay, what about Go ahead, Brandon.
Real quick on that, I think it's an important point. Look, you know this when I came over here, and there's others that have said this as well. Like, cool, so you're building a transaction, a highly performant transactional file system on S3. How those API costs treating you? Like, you're going to get brutalized on the API costs. And one thing that I thought was just remarkable, right, is that we have data to show across fleets of hundreds of customers that the average S3 API charge and the underlying storage is less than 1% of the total cost of S3, unlike the typical 15, 20, 25%. I mean, that's remarkable. I think there's, maybe you can dive this into a little bit, but there's stuff going on the read side and there's stuff happening on the write side to make that happen. On the
Yep.
read side, you talk about the preemptive NVMe caching, which serves out about 95+% of all read IO. So that means not only do you get 95% NVMe performance out of the cost of an S3 based system, but a 95% reduction in read IO to GET requests, which
Yep.
is a huge component of the API charges. What's happening on the write side to also mitigate?
Great segue. That was going to be my next piece that I was going to talk about, which is what do we do with the EC2 and the EBS volumes, and how much do you need to configure? Well, the good news is the customer doesn't need to worry about that. The EBS layer is used as a protected write-back cache. This is an example of belts and suspenders. EBS is already a durable block storage layer. But then what we do is you attach a bunch of small EBS volumes. Mike's got the exact detail. What is it? 8 gigabytes, 16 gigabyte volumes. Is that what it is, Mike?
I would generally think of the ratios that you might want to deploy with. There's no locked in anything, but as gigabytes or tens of gigabytes of write cache, probably terabytes of NVMe, and then you can have petabytes of S3 storage.
Yeah. And the EBS layer is essentially acting as a protected write-back cache. And what this does is when you have a lot of writes coming in, it acts as both for journaling the transaction, the distributed transaction to deliver consistency in a file system, and it's also coalescing this data. And that's kind of important. Imagine a case where you got hundreds of small files that came in. You could very well be generating hundreds of put requests on S3 if you're not careful. Whereas what we do is we actually coalesce that in the right cache, put them all into a single object or a smaller number of objects, and that sort of gives you that same win on the right side that you get on the read side.
Now, on top of that, we're also compressing data as well. Is that correct?
Great point. Absolutely great point. We are compressing the data just before it gets written out to S3, which means typically customers, depending on the data sets, are seeing anywhere from as low as 0 if you've got uncompressible data to as much as 30 to 35%, in some weird cases as much as 80% compression of that data when it goes out to S3. So not only do we reduce the cost from a API transaction point, it reduces the amount of data stored in S3. And initially when I started to talk to the AWS team about this, I was kind of a little nervous because I go, well, all of these things I'm talking about are the ways it reduces the use of the S3 primitives in the AWS world. And I wasn't quite certain how they would react to this because I have never worked at AWS, unlike you, Brandon and Paul. And it was shocking to me how hyper customer focused they were. Yep, that's a great thing. We should do that. How do you go drive it further down? That's fantastic that you're doing it. So that was quite refreshing for me to go hear that, right? And that's kind of what we do. So it compresses that further down, and it's pretty compelling there on that point of view. One last thing is, hey, what about auto scaling? Absolutely, you can auto scale. You effectively saw Mike Schmiel show the auto scaling except done by hand. And while we have not yet launched this, one of our smart engineers, actually on your team, Brandon, not even in the core engineering team, has actually already built a proof of concept where it ties Lambda functions to monitoring of network and CPU utilization on your instances, and then leverage auto scaling to automatically bring up more instances and drive it down. And what I find amazing about this is that is the power of the cloud. Once we built the core primitives, you had other people able to innovate around that, tie it to additional services, and sort of make 1 + 1 = 11. So all this stuff is about the technical piece, but I do want to go turn it back to you, Brandon, and talk a little bit more about the pricing. As you can well see, there are a bunch of questions around,
Yeah,
around pricing and licensing that people are
yeah.
interested in. So why don't you jump in and
By the
those?
way, that's exactly what I was talking about, interoperability and what you just mentioned, Kron. That's a great
Yeah.
Yeah,
example.
so that's CloudWatch using we report all of our real-time file system analytics to CloudWatch, AWS capability there, then Lambda function trigger off of that to be able to then create the auto scaling using CloudFormation and other AWS. So it even further things like using being able to run in local zones. So be
Yeah.
able to have the front end and local zone and the back end in the region to get closer to artists in LA, right? Reduce that latency, or being able to run in Outpost as a hot edge. So being as much, tightly coupled AWS integration as possible to really make it so that 1 + 1 = 11, and being able to have the power combined there. Yeah. So from a licensing perspective, right, this is all the underlying infrastructure that the system runs on is really up to the customer and goes through their AWS bill like normal. You can take advantage of compute savings plans, instant savings plans on at least the minimum 4 nodes to drive the price way down. And then the Qumulo software runs on top of that, but billed through AWS Marketplace. And so that can even count towards your EDP up to 25% annually. So you can get as much as that through AWS as possible. If you want a quick guesstimator, so to speak, you can go to our webpage, go to qumulo.com/AWS. There's a simple pricing calculator right there to show you total cost of ownership estimates for both hot and cold clusters. And that way you can get a basic understanding of what it would look like in totality, and obviously make it super easy to then go back to the marketplace and consume it from there. Did I miss anything else on the questions there, Carl?
Yeah, there was one question which was around flexibility in the licensing model, monthly billing, annual billing, prepaid
Mhm.
capacity, minimum buy-in. I'll let you answer
Mhm.
that, both in the
Yeah.
current state instantiation and the future vision, Brandon.
Yeah. So, first we have the option for you to buy what we call kind of Qumulo credits. You can buy, money up front, and then we draw down on that credit as you use it per gigabyte per minute, just billed monthly, very much like S3. It matches kind of eye for eye, just like S3 there. And that way you're only paying for exactly what you use when you use it. Clean up project, you stop getting billed for it. That can be broken apart into quarter or monthly, with true, pay-go and the rears coming in the future as well. But it's very, very simple to get started. And you can check out the details on the marketplace listing for us in AWS and go from there. Also, we have hot licensing pricing, which runs on S3 standard intelligent tiering, and then cold that runs on infrequent access or GIR. You can have those as separate clusters, or you could put it all in S3 intelligent tiering and just let it auto tier for you.
Well,
What else? I think that's it. Look, we're at time.
yeah.
First, a huge thank you to Paul. Thanks for joining. I appreciate the color commentary. It's like old times talking about this stuff. And I just love, again, the partnership, the collaboration, ultimately just working back from customers and helping solve problems. So thank you for being so Amazonian and being a great partner, even across, alternative technologies to solve problems for customers. So thank you again. Really appreciate it. Mike, Karan, thanks for being the brains of the operation and helping up level us here and show it live. And most importantly, thanks for building a product that is disruptively simple, cost-effective, elastic, and scalable, really being cloud native through and through, end to end for customers to find a whole new way to go about solving these problems with unstructured data in the cloud. So with that, thanks everybody for joining. We'll send out the recording. Karan, anything else that I missed before we close out?
Nope. Easy to try. As I said, go to qumulo.com/AWS. And if you have any other specific questions, reach out to us. We are all easily available. It's kbageshpur@qumulo.com, bwhitelaw@qumulo.com. Don't spam us, but please ask any questions. I love to talk to customers and prospects who've got other questions. We're here for you, and love to see you as using us, as many others are already using us.
Yeah. look forward to more in the future. Thanks, Paul, for the partnership, and we'll take it from there. Thanks, everybody.
Thanks, Steve. Bye.
Bye.